Text-to-image generation models are able to generate high-quality images, but they struggle to interpret human intentions, and thus often need multiple edits for final output. Existing work proposes sliders for semantic attributes that enable users to make precise adjustments to the attributes in a continuous space without altering other parts. These sliders are mapped to latent semantic directions to make such edits. However, there are significant user-centric challenges when we try to use them in end applications. First, the optimal slider range is unpredictable, with default values often being too large or small, depending on the prompt and attribute, causing confusion to the user. Second, slider variations are often inconsistent across the sliding range, leading to an expectation mismatch for the user, and makes it hard for them to predict next manipulation. Third, manipulating one attribute can unintentionally alter others due to the complex entanglement of latent spaces. We present AdaptiveSliders, a slider-based semantic editing tool that addresses these challenges by adapting to the specific attributes and prompts. Users start with entering the prompt, then AdaptiveSliders analyzes the prompt's semantics and generates potential attribute suggestions. It then aligns the zero value of the sliders to the prompt description, providing an appropriate starting point that enables maximum flexibility for the user's manipulations. Users can simultaneously manipulate attribute sliders within the adaptive bounds suggested by AdaptiveSliders to edit images. The images generated are consistent and stored in the history tracker. We conducted 3 validation experiments to evaluate the components of AdaptiveSliders, using a dataset of 100 prompts. Image reward metric shows that AdaptiveSliders was effective in finding a better prompt-aligned image than Stable Diffusion XL. In an experiment, users preferred adaptive bounds from AdaptiveSliders as compared to fixed bounds from baseline. In an experiment, users preferred the variation from AdaptiveSliders over the baseline variation. Finally, we conducted a user study to evaluate the impact of slider manipulation technique. We compared AdaptiveSliders with the baseline. The baseline is a version of AdaptiveSliders where our consistent variation and adaptive bounds techniques were disabled. Study includes a reconstruction task from the original image to target image. The participants performed 9 tasks in total with the use of 1 slider, 3 slider and 5 slider manipulations in reaching the target. We found that AdaptiveSliders significantly improved users' performance, enabling faster and more accurate achievement of target outcomes with less effort. Overall, users felt confident in using AdaptiveSliders because the bounds and variation were matching their expectations. For more details, please refer to our paper.